Welcome to Engineering Scale Models. I am Jason and I do models. Let's talk about my bench test equipment. All my bench test equipment has arrived for a 2-month trial, and I plan on some fantastic projects, talking about all of them and implementing stuff with some logic. And then I have a special project that is arriving today on September 24th. I'm not sure when this video is going to go out. It might go out today, it might go out tomorrow. But I have some special equipment that's going to come that is going to put all this test equipment to the test. So the question is, why I picked Siglent. I had contacted a few companies about getting some loaner test equipment. And this was back about 2 Septembers ago. So about roughly 2 years. And my channel was just starting out, and nobody would give me any kind of test equipment. So I needed an oscilloscope for a project I was working on, and I did my research, and I had a choice between a Rigel and a Siglent, and I picked the Siglent. I did. I like it. I like the fact that I can get the logic analyzer for it, and you need a license, but I do a lot of logic work, and I've always been interested in logic, and I got a lot of projects coming up to where I use logic instead of microcontrollers and things like that. So I picked the Siglent oscilloscope, and I can show you that right now. So I picked this Siglent oscilloscope here. This is going to be super bumpy camera rights, guys. I'm not using my main camera, I'm using a webcam. So I picked this Siglent oscilloscope, and I couldn't be happier. It's a 4-channel oscilloscope. It does more than I can ever hoped it would do. It does things I'm not even sure how to use, but I'm slowly learning it. And it has taken me the 2 years that I've owned it to learn how to use this oscilloscope. And now that I've come more familiar with it and I can use it faster, I've been featuring it in more videos and doing more things and expanding on projects in ways that I never thought I could. So speed up to about 4 months ago, I came up with the project of the traffic lights for scale models, because I wanted to do a way to incorporate some electronics into scale models. And we go here, and I came up with this traffic light program that I'm going to put on some surface mount LEDs and some actual traffic housings, and may 3D print them. Might do some videos on how to draw stuff in Fusion 360 and then translate that to a 3D printer. This is going to be an intensive project. It's going to take a while. This one right here is being coated with an Arduino. I'm currently working on making one that uses only logic chips, so it'll be on a small PCB board with a power supply and probably a voltage regulator, all surface mount, and get the program to work with logic and an Arduino in case you don't want to throw a Nano on there and run it that way. You get more functionality and probably easier with the Arduino, but I'm fascinated by logic and how you can do everything with the standard 3 logic gates, and it's just amazing. So I'm real into logic. I always have been ever since high school, and I started learned digital circuits and stuff. So I'm exploring that option and incorporating it into my scale model work. So you get the traffic program with Arduino, and then if you see here, I'm working on my TTL logic series, and the oscilloscope has come in very handy for that. So like I said, about we're in the middle of the coronavirus here in 2020 in America, and it was the middle of summer for my son. He had done some online school at the end of the year, and then we had about 3 months off. And then, so it was about the middle of summer, I would say end of June, early July. I reached out to a company that sometimes lets people do loaner equipment for reviews and stuff. And they offered me some Rigel equipment. This is the same equipment I have: 2 meters, a function generator, a electronic load, and a power supply. And I thought about it. I was like, yeah, they were gonna loan it to me for 6 months, and then a chance to buy it at a discount at the end. So I was like, yeah, but Siglent has this thing where they have software that is all links together, and you can transfer stuff with USBs. So I turned down that offer, and I got in touch with a company that distributes Siglent equipment, and I agreed after talking with them, exchanging emails, and finally I got a phone call from their product distribution PR sales guy, and I convinced him. He wasn't for it, but I convinced him to let me get the equipment on loan for 2 months, and then I would purchase it after the 2 months. So I don't currently have the money, but I have 2 months starting from today. So November 24th is when I either have to send this back or purchase it. So I'm going to be featuring in all my videos, and then you can help me pay for it if you guys so choose. If you want to help me afford this equipment, I have a GoFundMe set up for it, and I also have my Patreon. So any little bit dollar helps, 50 cent helps, anything helps. So I ended up with the Siglent because it's all compatible, and I ended up with I have a meter over here. It's the SDM3045X, and then I have the Siglent SDG1032X. That is the function generator and arbitrary waveform generator. So that's great for injecting like clock signals and things like that. And then you saw the oscilloscope, which I own that, so I don't have to send that back. And then I have another meter here. This is another SDM3045X. I'm weird about having 2 meters. I've always been weird. All the 3 meters I had before this, I had 2 of each, just so I know if I'm measuring it, they're roughly going to have the same tolerances. So that's why 2 meters. And I did something interesting. I put a wire in the current down here, and then I made I can do it on this camera. I made a plug that I can plug different things into, and I labeled it current, and then I tuck it under my oscilloscope, but I'm not using it. Put meter than that, and then if I need current, I can just tuck my other one under there and use that one. So hopefully I don't blow my meter up, but I only did it on one just in case it goes, and there's fuses in there and things like that. And then finally over here is the last 2 items. There is the 3 output, 3 channel, 3 output power supply. It's got 2 main channels that can put out up to 32 volts at 3.2 amps. I believe I have the 110 version, so I believe if I put a 6 amps fuse in there, I can do 6 amps on each channel, but I don't need that much amperage. 3.2 is plenty for the logic stuff I have. And then over here is a dedicated 2.5, 3.3, or 5 volts at 3.2 amps, and then you can turn them on, all off, and it's got all kinds of different functions. And then what I am interested in for when I start building power supplies is this SDL1020XE. is a 200 watt DC electric load. It has constant current, constant voltage, constant resistance, constant power, and you can do it to where it toggles the amperage up, down, and you can test your power supplies to run the load and to not and you can graph it. I believe you can even take the monitor out from this and plug it into my oscilloscope so I can check for any kind of droppage that would affect my logic, because logic gates have a logic level where if the voltage is too low, they won't trigger on the they just won't trigger. And testing power supplies to make sure that they have that voltage and they can provide the amperage that the circuit needs. This is an interesting thing, because it happened to me on this JK flip-flop here, and I didn't show this in the video for this. That video is very short. It'll be coming up soon probably, but I will give you a demonstration of the power supply of this here. Let me just show you. I'm going to be featuring this in all my electronics videos. I have a basic electronics series where I'm going through the Make Electronics book, and then I have I have this logic series, and then the traffic light program. So it's a good reference. The logic series is more a reference for me. If I need to know what a chip does, I can just watch one of my videos and see how I hooked it up and stuff. So I'm going to turn on the power supply. It's going to give me 9 volts at 130 milliamps. The circuit's not taking anything now. When I turn on the power supply, I'm drawing about 40 milliamps at 9 volts. But it's got a voltage regulator, and it's taking it down to 5 volts. And now I can work this JK flip-flop, and I can press the clear button to clear it. But if I swap this green LED with this blue LED here, so green LED with the blue LED, so, and I set this, so I gotta set it, so I set that. Now if I go to clear it, it won't clear it. It won't clear it. And if I swap it back to the blue LED, go back to the green LED, it clears it. What's going on? Well, let's find out what's going on. Let's analyze this circuit here. So we're going to look at this meter here because it has the probes on it. So we're going to come down. Now I can put all these meters on the screen. That's for later videos. But we're just going to look at this. We're going to look at the voltage coming off of. I'm going to zoom out here. Really bump the camera, and I'm going to zoom out. So I'm going to put this here like this, and I want to measure the voltage coming to this. I'm going to plug in the ground over here. And I want to measure the voltage coming out of this switch is 5 volts. Okay, but when I press this, it only drops to 2 volts. So when I'm pulling this low, it's not going low enough, because the chip needs less than 2 volts. It needs under 1 volt to trigger, or it's triggering the clear now, so it's dropping low enough, but it's not dropping to ground. It's not straight dropping to 0, because I have a voltage drop across this LED and across the pull-up resistor. So it does too. So let's see what the blue LED looks like when I press the button. So when I press the button with the blue LED, so I'm getting 5 volts there. When I press the button, it's 2.8 volts. And that 2.8 volts is too high for the chip to recognize it as a low. That's technically still a high. Now the reason for that is, if I look at the voltage drop across this LED is 2.8 volts, and if I measure the voltage drop across the resistor, it's 2. Well, I'm going backwards on that. So the voltage drop is 2.1 volts. So the resistor is dropping 2 volts, and it's not, and the rest is, it's not going to ground low enough with the blue LED in there. And this was bugging me, but I was able to. Oh, not in there. So is at 2.8, and then the green drops at the tip below. But I was able to, I tested it with the meter. I was also able to test it with the oscilloscope to see to capture the pulse and analyze it. I know that's a simple circuit to analyze, and it didn't take me very long, but it was nonetheless irritating. So at this point, I can only put output blue. Now, if I would have set these up differently to where it did pull it down to 0 and lit the LED using both sides of the circuit, I believe I could do that. But these are quick, just 5, 6, 7 minute videos, show how the chips work with just simple LEDs. I am pushing the chip to its max output milliamps. I switched to 470 ohm resistors. But if I hook up the meters and check current and everything works out, and the meters work great for checking current. I can also put the stuff on the oscilloscope. And currently I have a clock circuit built on this 555 chip, but when I need a cleaner clock, I can do the function wave generator to give me exact pulses, because later in the series there's going to be some chips that require a pulse and not just a high for a certain amount of time. Let me show you what I'm talking about on the oscilloscope. Let's just take a look at this Siglent oscilloscope here. This shouldn't be, because we're looking at this equipment, so let me just plug this in here. And I didn't plan on doing all these tests and showing you how the equipment works, but we're going to do it anyways. I will take my ground, I will come up here, and I will plug my ground in, and hopefully this will auto set to this signal. And no, let me so that's a pulse. Let's put on measure. It is a duty cycle of 47.20, so it's pretty close to 50/50. And if I what's the frequency? It's 1.7 hertz. So you can see it tells me 1.7 hertz, and it is 5 volts peak to peak, or from 0 to peak. So that is my clock signal. Now, if I come over here to my momentary clock signal, plug in. Let me unplug this circuit and plug in there. This is my momentary clock pulse. I'm going to set my trigger to single and see if we catch it. Oh, you know what? I'm probably not going to catch it. I'm on too high of a time delay. Yeah, see, that's the signal. Let's zoom in on that there. So that is no frequency. It's got a 4 volt peak. We can measure how long that is, so we can go to our cursors and we can take this one there, take this one there, and we can measure that of 121 milliseconds. So that was a 121 millisecond pulse, high pulse. Now, for some chips, it can't take a high pulse signal for 121 milliseconds. That's too long of a pulse. It's too much of a pulse. So you just need a slim pulse. And I could come in here and I can mess with this circuit, this 555 circuit, and with RCs, with RC circuits, and get it to more of a pulse, like I've done in previous videos on my shift register encoder project. I was able to get it down to just a pulse from a button, but it's not clean. It's not as clean as getting a pulse from a waveform generator. And let me show you where the oscilloscope really comes in handy, and one of the main reasons that I use it is let's take a look at this rotary encoder right here. Oh, well, let's take a look at a different rotary encoder. The one that has wires on it. So if I take these here and I change my leads on my power supply and I plug into the 5-volt section, didn't change anything, and I get out my little crocodile clips. So crocodile clips here. Love these banana jacks that you can just plug different things into safely. So I'm going to connect my ground to ground and power to power. And then I'm going to come in here with my other my grounded oscilloscope plug here. I hope I'm going to be able to do this. Okay, so let's just try this. There we go. So I'm going to take this and then I'm going to hook my pulse up to A here. Hook to A. And I will show you. Let's go back to single. Okay, my time delay is not. Okay, I need to set my trigger. Let's set it to a pulse, or actually edge. I need the falling edge. Edge. Slope. Falling. Oh, I didn't turn on the power supply. Okay, it triggered. It's just going to take a minute to load the waveform. But as you can see, now I can really zoom in on this. I can see that, and I can cycle through it, and I can see that I have a bunch of clock pulses that dip, and or not really a clock pulse, but a from high to low, and I was able to convert this into invert the signal to a clock pulse, use some RC circuits to build a little code crack game. It's still in the works, so I'm going to have more on that. I'm working on that series of using a rotary encoder as a clock and data input. So I got that project I'm working on, and I couldn't do it without the equipment that I have. So it is coming very handy, and I really like it. In the software, you know, I'm saying all good things about Siglent, but there are some slight downfall issues. I have the logic analyzer for one for the oscilloscope. It is cool, yeah, logic analyzer. It has the hookup, and then you buy the logic analyzer for $300, the little module that plugs in there, and then you have to get a license. So I have to sign up for a license in order to use the feature that this comes with. This has the feature on there, but I have to get a license to unlock that feature to use a logic analyzer that I have to buy. So the fact that, you know, I don't mind buying a logic analyzer for it, that's great, but to have a license on top of that bugs me. Now, as it comes to for software, I am happy with a lot of the software. Let's just open some of this software. Where is this one? Okay, let's take a look at easy power first. Let's go over to monitor 1. Okay. So this is the easy power one. We can search for our thing through USB. And it found our unit. Let's open it up, and this is the power panel. Yeah, doesn't even have information for output 3. It really, I mean, you can set it to, you can control it, you can do time setup, but the interface on the power unit does way more. And even just displaying this on the screen, I guess I could trim it down just to show what's on channel 1 or the channel I'm using. But yeah, so it's alright. Showing it on the screen is not really what I'm looking into. So let's check out the wave. This one is pretty cool. Naming these are all weird. This is the SDG. Is that what that is? Yeah. SDG. SDS. SDSPD. Okay, so it's this one. So, and then we can go to waveform, and then we can you know, we can create a waveform. I don't want to open, but we can basically create a waveform, you know, basis, and we can have it sent to channel 1, and then, you know, we can come in here and we can start with, you know, a square wave, you know, and then we can come in here and we can manipulate it with different operations. Here we go. Here's the ones. But I can, you know, make it do all kinds of different things. So this one's pretty good. This easy wave thing, that's pretty good. So I can create custom. I guess it would be a little easier to do it on the computer screen in front of me instead of programming it on the little screen of the function generator. So this seems, yeah, so this is a good program. I like it. Let's close this. No, I don't want to save it. Here is the Easy DMM, and it is, it's nice. It's connected to my thing. If I press play, it should display what's on there, and it failed to carry the device. So it gives me some issues. So let's add instrument, and it is the DM, and there it goes. Now it's showing what's on my meter, the meter to the right. So I can display this on the screen. I'll even show you what that looks like if I go to the main overhead. I can show you guys, that's what, you know, little corner of the screen. I have that on there. So if we go back to monitor 1, so that's the Easy DM. But now I'm locked off from my, let me just show you this here on the webcam. Now, if you look at the meter here, it's going to be hard to see with the lights there, but in this top corner, it says remote. So no matter what I push on here, even if I try to go, it won't let me go to local. So if I hold shift, nope, it won't let me go. So I have to actually physically go into the software here and stop it from running, and then I have to press local, and I can have power and control back to my my unit. I wish there was a way that I could just monitor it with no control, just see what's on the screen and display it for you guys. But to actually lose control of my meter and have to go in here and change it or drop it and things like that, I haven't come across a way to deal with that yet. So let's just close that. And this is the Easy Scope. So I'm going to add my device, and it is the SDS 1104X. And then I can go to screen capture, play it, and then I can see what's on my oscilloscope, and if I go to the camera I can display for you guys what's on the oscilloscope, and that's real time. So if I go back to run, you guys can see it's just a flat line, it's not hooked up to anything. So I can share my scope with you guys on a video without having to do the funky webcam setup. So that is that part. Let's go back to monitor one. So and this has a lot of different things. You can save a waveform. It even has this. See, this one has a feature. If I go to scope, it has a thing called virtual panel, to where I can. It's not live updated, but as soon as I make a change, I can go there. So I could have this virtual panel, but I can also just see what's on my machine and control it from here, from down here at the bench, so I don't have to grab the mouse and go up there. And I don't understand why the meter software doesn't have that option. So I'm gonna go back into the meter software, and there's no like screen capture kind of thing. You know, even scan data doesn't do it. I mean, there's no, you know, there's control. I can send commands, connect. I'm already connected. DM explore. So scan. It just doesn't have the screen capture feature. Like save data, I can save a data. I can go to settings, clear, see what settings does. Auto stop, save, delay, manual, trigger samples. Yeah, nothing to where it can just see what's on there and not have to have it. It's the one thing, you know, it's great software. I can show it to you guys on the screen, but not a fan of how I can't control it at my thing, which is why I have two. And I don't even know if I can have two running on the screen at once. So some of it you guys might see on webcam, some of it maybe on the screen. The scope, definitely something I put on the screen because it's crisper and, you know, you don't have that light shining down. The electronic load software, I just received the electronic load yesterday and opened it today. There's not going to be an unboxing because when it came last night at 9 p.m., the box was banged up and there was rattling inside. So I opened it immediately to check to see if it was okay, and everything seems to be fine. I haven't checked the calibration yet. I'm going to be checking it today after this video. So that is the equipment. It's on loan to me for 2 months. I have an option to pay for it. I can pay for it for a discount. I am currently saving for it. Like I said, and you guys can help me afford this equipment so we can do some cool stuff with it. You know, work on some cool projects. Links are in the description on how to do so. Thank you so much.